This is House Planning Help, episode 273. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build, because I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Paloma Gormley from Practice Architecture, and we're going to be looking at a house that's making use of hemp, because it's on a hemp farm, and you might as well. First though, if you haven't checked out the podcast before, well, it's designed to help you on your self-build journey. Hopefully you have your heart set on building an eco home, and obviously on this podcast we love sustainable design, and that will always be at the heart of what we do. But we're well aware you might be struggling elsewhere in the process. So let me know what topics you'd like us to cover on the podcast. You can email through the website, it's houseplanninghelp.com, or tap us up on social media. Again, you can find those links on the website. And if you're one of our email subscribers, and I'm certainly recommend that because we always try to send out useful stuff to you, then watch out for our surveys that we send out periodically, just trying to dig deeper into what it is exactly you want to know. So houseplanninghelp.com. Be lovely to hear what you want more of. So let's get to our featured interview with Paloma Gormley from Practice Architecture. It's been some time since we've talked about hemp. I think the last time was with Professor Tom Woolley. So this seemed like the perfect opportunity to dig a little deeper, as the flat house uses a lot of it. On top of that as well, we talked about plastic recently, so this tries to minimise plastic use. I started by asking Paloma to tell me a little bit about her background.
I studied as an architect. Did my undergrad in a kind of traditional way, I guess, at quite a old school university that was very interested in all the kind of pragmatics of building, and I think maybe that's where my interest in the pragmatics of building came from. And then in my third year of studying, I got an offer to build a cafe on the roof of a car park in Peckham. And thought sounded like a good thing to do. So I designed this small bar on the roof of this car park in the last few months of studying, and then pretty much the day after completing my exams, went down there and started building it. And I did this with a friend from university called Lettuce. And I think because we were incredibly inexperienced on all fronts, we had no idea that how it would work to think about getting a contractor involved. So it just was the obvious choice to go and build it ourselves. So we spent 2 or 3 weeks on the roof of this car park learning how to use power tools, which we bought from Tesco's, and knocked up this bar, which then became incredibly popular and is still being, this was 10 years ago, and it's still being put up every summer now.
Wow, yeah. What an introduction. Well, today we wanted to talk about a slightly different project and also material, I suppose. So let's start with the material, actually. What is hemp?
Hemp is a plant that's in the cannabis family, so you'll be very familiar with it, I'm sure. But the industrial hemp is a genus of the plant that has very low THC, which is the psychoactive element of the plant. So it's legal to grow it with a license in the UK, and the plant has a kind of multitude of uses. So almost every element of the plant, I think actually every element of the plant, is highly valuable in a functional sense, not necessarily in an economic sense. But the fibre, for example, you'll be very familiar with in the form of rope, in the form of linen, thing in jeans for centuries. So it's an incredibly strong fibre that actually they've been using in kind of aeronautics and in automobile industry for a long time, but no one's talking about it because it doesn't kind of align with the identity of those industries. And then there's other parts of the plant. So the seed has enormous nutritional value from the oils that it contains, and then the bud can be used medicinally, and the shiv, which is the main component that we're interested in, which is essentially the kind of straw, it's the stalk of the plant, can be combined with clay, or the way we've been using it with lime, to form this material which is known as hempcrete, which is a essentially an insulation, but it's an insulation that also has quite a lot of other properties.
Has hempcrete been around for a long time?
It's debated. Some people say that it has been seen in kind of early 17th, 18th century buildings, and others say that it's actually quite a new combination of materials. So although it kind of comes from a lineage of natural materials and clay and binders, etc., that actually this specific combination is a relatively new thing and has only really been around for about 15, 20 years. And in that time, its use hasn't grown massively, and people have been aware of it for that long. But there's just quite a lot of barriers, be they kind of cultural or still actually legal.
It hasn't really been used, hemp, as a plant to its maximum potential, has it? There's no debating that.
Not at all, no. I mean, not for a long time. I think back in Henry VIII era.
Oh, really?
They were much more aware of its benefits and its potential, and before the growing of it was outlawed, the cannabis plant, I guess, more generally, it was an incredibly ubiquitous crop across the country.
Now, what comes first for you? Is it this particular project that is going to use it, or have you had a long love of hemp and using it on buildings?
My relationship with hemp began from a friend of mine who's set up a hemp farm. It's a group called Hempen, and they have an amazing hemp farm in Oxfordshire and grow for a number of different things. And they grow on a kind of medium to small scale, and they do all of their own processing. And on another project that we did in London, it's kind of a 3-storey house, he'd suggested it early on as a material, and it ended up being the most practical material for the building that we designed, which was a nice introduction and serendipity. But so we used it in that building, but in quite a different way. That was a self-build project, and we used a lot of timber, really hefty Douglas fir frame, and then cast in situ hemp that infilled between this portal frame structure. But that project was very idiosyncratic in a way, and it's got a lot of character and a lot of flavour, but it's quite a different intention, I guess, to the more recent project at Margent Farm, which is kind of highly rationalised and pragmatic in some senses, and is looking at off-site construction, so factory made.
Well, I was just going to say that isn't one of the challenges of this getting the mix right?
Yeah, you mean of the hemp and lime? To an extent, it's once you've, you can probably learn how to get the mix right in about half an hour. So it's not
that much of a challenge.
Not much of a challenge. No, yeah, I wouldn't.
Or
say
is it slow? Is that one of the?
Yes. So there's an issue with drying times and curing times. So depending on the binder that you use, some of the more reliable binders have a kind of cement content, which ideally you wouldn't have. And there are binders that are pure lime, but they are slightly more awkward to use and either set too fast or too slow or don't hold. So you're right in that sense that, yeah, if you're going for the purer, which we should be aspiring to, limes, then it is more slightly finer art in terms of getting the mix. But then the other barriers are that it sets in about 24 to 48 hours, depending on the binder. Actually, it can be quicker. But then the drying times are incredibly long for what we are used to in this industry. So it kind of averages out at about 3 months for the building to kind of dry out, and that's slightly dependent on temperatures and airflow and et cetera, et cetera. And until it's dry, you can't apply any secondary finishes.
So taking that process off-site, how does that change things?
It means that you're taking the wet process off-site, which means that the site becomes a kind of streamlined construction process on-site, and it's what they call a kind of dry process, cleaner, less complicated. it means that drying time can happen somewhere else before you come to the point of assembly. So you're not waiting around, but these things arrive dry and you can put whatever finish on. And it also, maybe this is the most important thing, it extends the construction period. So one of the other limiting factors with hempcrete is that you don't want to be casting in the kind of winter months, because there's a risk of, before the hemp dries out, that there's kind of too much dampness in the wall for too long. There's all kinds of problems that can come from that. So that can have a disastrous effect on a construction programme if suddenly you kind of run over and then you've basically got to down tools for 3 or 4 months. So the cassettes arriving dry, the hemp dry, means that you can build 12 months of the year.
Is this something that is trademarked, a product that you're using, or off-site in a different sense?
It's not trademarked, and it's very simple. There's nothing particularly clever that we're doing.
Okay, you're just taking it off-site to control. Yeah, okay.
Exactly.
Tell us about the site then in Cambridgeshire.
The site that is what we call Flat House, it's the first flat house, has been built on, is itself a hemp farm. It's called Margent Farm, and they have been growing kind of 40 acres of hemp, and I think that might be expanded in the coming years. And Margent Farm are in themselves an organisation, and they're researching, they're doing R&D and developing products around hemp-based plastics, so bio alternatives and solutions to plastic products. So they're making a whole spectrum of things, from the cladding that we developed together that's on the building, which is a hemp fibre with a sugar-based resin, and the sugar resin has been derived from agricultural waste, so it's things like corn cobs, so that central, tough, starchy bit in the middle of the corn cob. Things that would otherwise be incinerated or go into a waste cycle. So those two things are combined and then pressed and heated to a temperature of 180 degrees, which is a very low temperature relative to kind of other heat moulding processes. You know, it's the temperature that you'd bake a baked potato in the oven, and then left to cool, and they're ready to go, essentially. So they're potentially coming, I think they are coming to market in the spring.
So how much of this house is actually just from the fields outside?
I haven't actually done that calculation, but it would be a very good one to do in terms of volume. I imagine it's
but a good chunk. Yes, don't worry, I'll set you up on this calculation.
Yeah, my brain's ticking. Probably something like 60 or 70% in volume. Maybe could be substantially more, actually. So the fibres in the cladding, in the sheet cladding, and the hemp infill in the walls all come from one harvest, and there was a lot of that harvest left over. So yeah, it's a decent amount, and then the rest of the materials are kind of timber and all cellulose things, which also have a very low embodied carbon, which is maybe something that we haven't covered about hemp. So one of the reasons to use hemp is that it sequesters carbon more than most other plants during its growth. So as it's growing, it absorbs, it's sequestering carbon into the body of the plant, but also into the ground, into the soil, and it can be used as part of crop rotations. And
am I right in thinking that it's actually a pretty good crop for growing quickly and then being used?
Yeah, it depends where you are. At Margent Farm, they do one harvest per season, so per year, essentially. In other countries and in other regions, I think you can get 2 to 3, which is pretty good for a crop of its kind, yeah.
What else was on the brief for the house?
I guess they wanted somewhere that had a good relationship between the house and the landscape, so it was very important that it was connected. It needed to be incredibly low embodied carbon, and crucially to avoid plastic use absolutely wherever possible.
What sort of things might you instinctively be talking about?
In terms of plastic use, it's everywhere in our contemporary buildings. So enemy number one, maybe, polyurethane insulation. Otherwise, there are kind of various brand names which we're probably all quite familiar with for that. It's the kind of rigid foam insulation that we all know, which you'll find in many, many buildings, and sadly, more often than not, even more of it in buildings where they're reaching high ecological credentials, such as passive house buildings, because they rely on extraordinarily low U values, and they achieve that often with rigid foam insulation, or
and sometimes underneath, you need it underneath the house.
Yeah, polystyrene foams. So most of our insulation products will be petro-based plastics, and then the membranes have your internal vapor barrier, which is polythene, I think, and then your building paper, which is another form of plastic. Most buildings are kind of put together with sellotape, sticky tapes of all different kinds and descriptions in all the different layers. And there's generally a fair amount of expanding foam that just goes here, there and everywhere to fill up all the cracks and gaps and goes around windows. Nylon thermal breaks to mediate thermal bridges between inside and out. All of the gaskets, etc., that we put in our windows, UPVC windows, pretty much. I mean, it's all the stuff, I guess, that you don't see or becomes invisible to the eye. And then all of the stuff in the walls, wiring, ducting, pipes, vents.
So how did you do that?
Well, we didn't achieve it 100%. And there are barriers in terms of cost, and there are barriers in terms of, certain things just don't exist. But we did pretty well, and we did that partly by returning to what is known as breathing construction. So breathing construction refers to not so much air leaky buildings, but buildings that can transfer moisture through the wall. So all of our buildings pre the last 50 years did this, and they'd take moisture from the air inside a room and kind of absorb it into the wall, and then breathe it out the other side. And there's many reasons why that's a really good thing. Kind of limits condensation. You can kind of have a self-regulating moisture content in a room, because the moisture content of a space gets too high, it just gets pulled into the walls and then evacuated. And it means that when something goes wrong, you know it's gone wrong, because breathing construction generally involves a much more direct relationship with material. So it's more a case of what you see is what you get, whereas with kind of layered construction and petrochemical-based construction, you're generally kind of 5 layers away from structure or pipes, or maybe not that far away from pipes. But you're in some kind of veneer. You're within a veneer of what the building is, which is fine, and that's what we kind of got used to. But it just means if something goes wrong, it can be quite hard to identify it, particularly with things like leaks.
Did you have some air tightness targets and things like that, or was that not really going to be, it's sort of almost at the opposite scale of what you're doing?
To an extent, air tightness is, I don't know, there are people trying to convince me otherwise at the moment, but it begins to feel less relevant. I mean, I guess the other thing that we did was we didn't service the building, so contemporary building methods generally, there's an expectation of effectively air conditioning, which means more pipes, more ducting, more soffits, more, all of that stuff that we kind of wanted to strip away. So you always have to have a level of background ventilation, which we used to achieve by just having slightly leaky buildings. Now we're making incredibly airtight buildings and then making intentional holes, which is, I think, just a kind of funny logic in a way. There's so much, generally plastic, goes into making incredibly airtight buildings, and then we punch holes in them. And the idea is that those vents are regulated, we kind of close them and open them. The reality is no one closes them, or even often no one opens them. So yeah, often these buildings, the background ventilation doesn't actually get activated.
On a building regs, we're talking about something where you've got trickle vents, or
yeah, it's a building, exactly. It's a condition for building regs that you have a certain amount of trickle vent or background ventilation. Basically, that means that the air that we're breathing has enough oxygen in it and is being replaced enough times during the day without us having a window open, which used to happen naturally because we didn't used to go so crazy on sealing up our buildings. So it's a difficult one. So it's not something that we necessarily are looking to achieve fantastic rates on, because we're not looking to condition that air, extract the heat loss from it, but we're looking to make kind of well thermally insulated, incredibly low embodied carbon buildings.
And what did you do for things like windows? Were they timber windows?
They're not timber. They're aluminium, which is an incredibly high embodied energy material, but it's also one, I guess another factor in all of this is kind of circular economy thinking. And aluminium is the only metal that actually gets higher quality the more times you smelt it. And it's got a very high market value, and is always recycled because of that. And they're quite high functioning as well. They could well have been timber. There was, cost concerns. So the bad thing about aluminium is the energy that it takes to manufacture, and ideally, we'll move to a world in which we're producing energy without producing carbon, in which case it does begin to feel like a fully responsible choice. At the moment, it probably would have been, in terms of a kind of carbon footprint, aluminium would not necessarily be the one to go for.
Well, no building is perfect. We just like to talk them through. What about then, maybe you can talk us through the construction from the foundations right up, any challenges in construction?
Yeah, so the footings are almost the most difficult bit to get right. Since building it, we've come across quite a few interesting ways to think about foundations. It's got conventional concrete foundations, and then a kind of raised, suspended timber joisted floor. The foundations were reasonably substantial, and so since building it, been looking at things like, screw piles, which have been around for a while. They're dependent on the type of soil that you have, so you can't use them in every condition, but they're essentially giant screws, steel screws, that you need quite a small machine that kind of hammer drills them into the ground. And they go a certain depth depending on the ground condition and depending on the weight that you're loading them up with. And the benefit of them, they're kind of relatively low embodied carbon. Steel's still pretty high, high embodied carbon in its manufacture, so it's not negligible. And the idea is that, again, thinking about circular economy kind of models, that they can be unscrewed. They can be taken out of the ground again and used in another project. The maybe even more exciting alternative is compacted hardcore or compacted flint, compacted stone, or even stone itself. So using stone in blocks as pads, using compacted flint to make it, making a trench, filling it with flint and compacting it. So there's a project that the brick factory that we work with have a kind of nearing completing, and that had these compacted flint foundations, and the flint is coming literally off the ground, out of the fields surrounding that factory. So there's a very direct relationship there. But I think that's something that we're going to really explore and invest in finding a solution to, because it just increasingly feels completely crazy to be putting so much concrete in the ground.
So that's foundations, walls, roof?
So the walls we developed a cassette system for. So this is the kind of innovation of the project, I guess, essentially. They're super simple. They're based around an 8x4 sheet, and they were made in a factory as kind of boxes, essentially, laid on their backs, and then we filled them up with hempcrete and dried them. And then those were brought to site and erected in 2 days with a crane, very simply kind of screwed together with face-fixing additional pieces of timber that screw on the front. And then the roof, it's just a very straightforward, they're kind of joisted, that's not the right, they have a different name when they're in roof construction. And then we used this stuff called wood fibre insulation, which is, if you can kind of imagine MDF, but filled with air, even lower the lowest density MDF you can imagine. So
it's got a nice feeling, the wood fibre.
It's brilliant stuff. I only found out about it relatively recently, and I couldn't believe it had taken so long, because you can do everything that you can do with the rigid foam polyurethane insulations with this stuff, and it's got almost the same U value. That's not quite true, close enough to the same U values, and every builder would be able to use it in the same way that they use those other insulations. So it's really brilliant stuff. So for a kind of immediate solution, an accessible solution, that stuff is great. We just need to get it being made in the UK, and then it will be.
Yeah, the next thing, the transportation. Yeah. Anything else that we should know about the flat house or the construction of it?
Yeah, so we're with material cultures. So the flat house kind of led into the establishment of an organisation called Material Cultures, which is explicitly to kind of research and explore these materials in the space of off-site construction. So at the moment, there's kind of 3 massive new house building factories that have gone up across the country, and they're using a kind of spectrum of materials, and some of them are kind of using engineered timber quite a lot, but they still have some of this palette of petrol-based insulation, etc. So we're really interested in finding ways to make these materials more accessible, make them more affordable, and make them available more broadly. So we've established this organisation called Material Cultures that has a base at the brick factory that I mentioned, and we're kind of setting up to begin manufacturing at a larger scale now. So to draw from the model of the flat house, and then we've been working with UAL and UCL, 2 universities, to develop it as a research project. We've developed another prototypical building with UAL, with the students on the architecture course there at St Martin's, and those things are kind of feeding into the broader research. So it feels very important to us that this project and these processes happen in a very reflective way, constantly learning and moving and developing the thinking.
Have you mentioned all the lessons you've learnt from this?
God, no, probably not. There'll be so many.
Well, give us a couple then.
One of them, I think, has been the relationship with the client at Margent Farm, and he is a filmmaker, and he thinks in terms of narrative, which has been an amazing exposure to a way of developing a project, because I think I've always approached things in maybe overly pragmatic point of view. But that entire project came from an idea and a story that he followed through from beginning to end with integrity and loyalty to the story, maybe more than the kind of pragmatics necessarily. And I think in the end that's taken us down some extraordinary paths that we probably wouldn't have gone on anyway. So I guess to kind of keep romance alive in the kind of pragmatism and reaching your end goal.
Not one that I was expecting there. Now, how is Steve finding it, the house?
They seem to love it. Yeah, they're there a lot, and they've got a cat who's also moved in, and everyone seems very happy. It's been amazing going from an idea to someone's home, and it seems to be kind of facilitating the next stages of the things that they're doing and the development of all their amazing products.
And you'd like to go down this sort of route again? You know, it's been interesting for you.
Absolutely. I think I'm hooked. Yep. Going to be on this path for a while.
Paloma, thank you very much.
Thank you.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/273, where you can check out the main points once again in our summary that we always provide. Also some photos, construction, right through to completion, what it looked like at the end, all that hemp. If you've got a comment or you'd like to ask a question, then head down to the bottom of the show notes or get in touch on social media. And of course, we'll link to Practice Architecture and the other resources that Paloma mentioned through the episode. houseplanninghelp.com/273. And if you like the podcast, well, don't forget there's more in our membership community, The Hub. Just head to houseplanninghelp.com/join. What we're aiming to do here is really continue things. You know, I run a production company, so I like to put lots of video in there. And we've got live training session with guest experts. We've got resources to help simplify the self-build journey. And as I mentioned, we're trying to improve it all the time. We're open to your suggestions as well. houseplanninghelp.com/join. Next time, Matt Barnett-Howland from CSK Architects is my guest. And not only has he built the world's first cork house, but it's ready for the end of the life cycle, having been designed with disassembly in mind. So that all sounds interesting. We'll get all the details for you next time. The House Planning Help podcast is produced by Regen Media, content that matters.